Welcome to the Rust Code Clinic. In this series, we showcase how our private students sit down with our Rust mentors to review different Rust projects and become better developers. This Rust Code Clinic episode features our mentor Cliff, who's a principal engineer, and one of our private students, Arturo, who's a senior full-stack engineer. Arturo is particularly interested in building cross-platform, high-performance desktop applications in Rust. The project he's building right now is a cross-platform, lightweight music player in Rust using the Iced framework. The core feature is a powerful user-defined tagging system with a customized UI optimized for keyboard-driven song tagging and advanced playlist filtering. And Cliff, our mentor, will be helping Arturo architect his audio pipeline and refactor the complex logic for his project. If you also want tailored mentorship like this every week, go to letsgetrusty.com/join or click the link in the pinned comment below and join the waitlist for the next Rust Live Accelerator cohort. I learned quite a bit from this Rust Code Clinic session, so grab some popcorn and enjoy this episode.
Yeah, and I think that's the part where you had more questions. You had a question about how to kind of work with the audio pipeline. There's some kind of you have some ergonomic issues that you were concerned about. You've got some state in there with options that are being used to kind of compose your audio pipeline that seem very cumbersome to use. You had a question about the resampler, maybe how to clean up that implementation. You had some questions on errors and tracing. And then you had a question on wiring up communication between the app and the playback controller in a way that is idiomatic for Iced, which uses subscriptions to manage communications between the UI portion of the framework and like background threads and tasks, that sort of thing. Great.
Yep, those are pretty much my questions. So yeah, let's go ahead and take a look at the playback module of this code base.
Yeah.
Basically, the entry point to communicate with the overall all things related to the playback is this struct, which is playback controller, and it basically just orchestrates two things: the audio engine, which is what I use to output the samples that I decode into the OS, so it produces sound. I do this with CPL. I can show you. It's a pretty relatively simple implementation. And the other thing that I have in this controller is the pipeline. The pipeline refers to picking up commands for decoding the song. First getting the song from the file system, getting the decoder, the mixer, getting the resampler, and performing the necessary steps to get from the raw track file to samples that you can output to the audio engine through the sync. The sync is basically just a struct right here that I created so that I can communicate, let's say, more cleanly with the ring buffer that fits the audio engine, because the ring buffer can get filled up by samples. Basically, this struct is just for having some sort of buffering when you cannot introduce all the samples that you decoded into the engine, right? Because the ring buffer can get filled, and then you have to figure out what to do with those samples that you have remaining. And yeah, that's pretty much the morphological structure. Here's the audio pipeline, as you can see. Here I have the decoder, the resampler, the sync, the channel converter for like converting from mono to stereo and vice versa. It's just a pure function like this. That's pretty much the different parts, right?
So just so I understand the pipeline. So basically you load in, do you load the entire file all at once, or do you stream it in while it's playing back?
Yeah, I stream it.
You stream it in.
Because one thing that I want to aim for with this music player is that it's pretty lightweight to run, because again, it's just a music player. It shouldn't take that much space, like in terms of RAM, sense of processing and such. So I'm like trying to make my decisions err to the side of a lightweight implementation that is efficient, so to speak. So yeah, that's why I choose streaming over just loading the whole file. Also, I have files that are like half a gig in my
Yeah.
in my personal library. I don't want that loaded into my RAM. So yeah, that's another
So basically,
motivator.
your pipeline consists of a segment that reads in some portion of the next samples from the file. You then decode them. Is the decoder the next stage that decodes from the file into some sort of neutral format internally?
Yeah, I mean, you can see how it's built.
Mm-hmm.
Going to show it so it's more like clear.
Mm-hmm.
You first take the muxer and extract a package. Well, a packet is the correct name. That packet contains data that then you pass to the decoder, and from then you have the samples that were decoded from that packet.
Okay.
After that, you have to resample them optionally. You can have tracks that have the same sample rate as your output device, so it's not always needed. It's an optional step. And there is also another optional step, which is channel conversion. If you have a mono track and you have a stereo device, you need to like convert it. And the samples, this is more into the territory of theory related to audio and such. But the samples for a stereo track, for example, come from the decoder in this specific implementation. All the samples to the left of the headphone, the left speaker, I'd say, and all the samples to the right. And then you have to use an internal method for the buffer that you get and get it interleaved, because that's how the output, well, the engine understands the stereo output. One sample for the left, one sample for the right.
Okay.
Left, right, left, right, left, right, like continuously. And yeah, that's pretty much the implementation. If you have like mono tracks, you need to like, you're going to just get the one sample per frame. By the way, I should have introduced the concept of frames, but a frame is just like the necessary samples to like make noise in all the speakers, like all the channels. If you have stereo, you need two samples. If you have mono, you need one sample per frame. So I was saying, you need to convert between stereo to mono by creating the necessary samples to fill in the missing channels, or convert down to the lower amount of channels.
Mm-hmm.
Like when you're going from stereo to mono,
Mm-hmm.
you need to like do an average between the two samples that go to the left and the right, and then like that's your mono sample. Basically a combination of the two. And I know I went deep into theory, but
Yeah.
is there like any questions related to the implementation?
No. So that I pretty much, yeah, that I understand, or at least I remember that much from way back when I did some audio stuff. So it's good to refresh that. Yeah. So why don't we dive into the questions you had, and then we can just kind of go from there.
Sure. So I got them right here.
Mm-hmm.
Yeah, basically I want to critique on how the audio pipeline is currently structured, because I have the problem right here where I need to extract these optional pieces that may or may not be initialized depending on the state of the UI. Let's say you can have an output connected to the engine, but you might not have a track. And the opposite can happen too. There's that situation that could happen there, and I need to account for it, as you can see, not going through the coding if any of the necessary pieces to produce audio is missing. So
I see. So this particular section, this is in which function? Oh, this is in function process in the pipeline.
process. Yes, this is getting called in the code loop in another thread.
Okay.
I should have shown that. It's right here.
Okay. Yep. I see there. Okay. So you either continue, stop, or you have some sort of error.
Yes.
And is break basically the friendly stop, the user stopped it, or the track ended?
Actually, I implemented this for tests because I was having the problem where the threads were basically hanging where they shouldn't. Like if you close the process, obviously the process is going to get killed. I'm not sure, but But I was observing that it could like interact with the other tests in ways that are not, how do I say this, not predictable,
Okay.
I think. So I added this drop behavior to the playback where you basically just send the exit command and then you wait for the handle to like return.
Okay. Okay. So let's go to the structure of the audio pipeline and how we can maybe make it a little more idiomatic. So the way that I would normally expect this to work, if I had not looked at your implementation, but I'm just thinking about, I want to have a music player, and I know that I'm going to be basically reading files, doing some transformations, and outputting some data to something that's going to produce sound. In this case, that's the target for your sync. My expectation would be that I will construct that entire pipeline, and it will have all of the information that it needs to be a complete pipeline. And that is the point at which I will start pumping it or running this process command, right? So for example, maybe it's the case that when the application starts up, it knows, okay, the sync is going to look like this because I have this audio device attached and it needs this many samples per frame or, or whatever it is. You've got, because you know about the sync and you know what the destination is, something about what the resampler might need to be, but you don't have everything yet, so you can't quite construct it ahead of time. You might have to defer it until you have started to load the application or started to load the audio file. But my expectation would be that once the user has loaded that file before they've hit play, we should have all of the metadata that we need to construct all of the pieces of the pipeline, right? So we will know what the source format is. We will know all of the transformations that we need, whether we're going mono to stereo, stereo to mono, whether we need to resample up or down to get to the sync, right? So we'll know what the parameters are for the resampler. We already know the sync. So we should be able to put all of those things together. And my expectation would be at that point, you might then construct your audio pipeline, right? The real one, that doesn't have any options in it, but it does have all of those pieces filled in. And then that might be the thing that you hand off to your thread to say, here's a constructed audio pipeline specific for this file that we just loaded. Go and process that. So then you would be free to, as you load in new files, you can construct new audio pipelines. You can even construct them ahead of time. You don't have to start running process on them until you hand them off to whatever your thread is that's doing the work. But that would be like my theory about how you would avoid the situation where you keep looking for things that maybe aren't ready to go yet because you're not in a state in the UI where, I haven't loaded the file yet, or for whatever reason, like I don't have all the metadata that I need. Does that make sense, or had you already gone down that route and had to discard it for some reason?
I think it makes sense. This will mean that the pipeline will get destroyed and created continuously, right? When we reach a state where some of the pieces are missing, because let's say, for example, any of the pieces related to the input and the output can at any given moment be absent because, let's say, the user just, now that I think of it, you cannot unselect a song, but let's say the playlist ends and for some reason we reach a state where we are idle and there is no decoder, no nothing for some reason. Or, for example, the output changes because the user disconnected their headphones, or I don't know, they selected a different piece of audio in a dropdown in the UI. At any given moment, the input and the output can change. And if you change the input particularly, you have to basically recreate the decoder, the resampler, those pieces that are related to getting usable samples for the engine. Yeah, I was wondering, how would that work?
Yeah. So, looking at this from, let's separate this into two kind of phases. There's the one phase where you don't have an audio pipeline fully constructed yet because either something is missing or something has changed. And so your previous audio pipeline is no longer going to be valid, or you didn't have one before, but you don't have enough information to make one first. So that's like one phase. The second phase or the second part of the application is where you do have a fully constructed audio pipeline and it's ready to go, right? And you can just use it. I think of those as like in the UI, the user is making some choices. And UI here doesn't just mean the UI in your application where they're, punching buttons or selecting files or all that sort of stuff, but it's also like they're interacting with something that could affect the audio pipeline in a material way. So changing the volume probably doesn't do that because it's going to be done at the system level, but like unplugging your headphones so that the system decides that the default audio device is now speakers rather than headphones, right? That might be an event that you get from the audio subsystem, and you're like, okay, now I need to do something. My audio pipeline was previously pointed at the headphones. Now I need to change the sync to go to the speakers, and that changes my resampler, for example. So I have to like do something about that. The easy way to think about this is all of those decisions happen basically in your UI, the UI portion of your application, right? So in the iced UI and any events that are coming from background services, maybe through subscriptions, that get posted to that UI, and you're responding to those, right? And what I'm thinking here is that you have a temporary, like it basically be like an audio pipeline builder. If you're familiar with the builder pattern, where you have an empty object which may or may not have some number of things set. And so you construct this empty builder, you call functions on it which are setting or changing various values in it, like you use this resampler, use this source file, use this sync, right? Those sorts of things. And the state of that builder can be indeterminate at any particular time because you might change something or you might need to turn something off or whatever. That stays on the UI side, and you never use that for producing audio. But at some point, you decide that like all of those things have been set, and then you execute a build function on that audio pipeline builder, and you get out of that an audio pipeline. And so that would be your current audio pipeline that you have, or at least all of the portions of it that are related to the pipeline pieces, the resampler, the sync, those sorts of things. Those are all in there, and they're no longer options now because you have them all, you collected them all in the builder, right? And so that when the build function is executed, it constructs an audio pipeline and hands that back. That now is a fully realized audio pipeline that we know will work, and that is the thing that we hand off to our processing loop, which is presumably running in a background thread because it needs to be pumped constantly and adding new samples and all that sort of stuff. You probably don't want to run that on a UI thread.
Yep.
And so once that's over there, that can just keep running by itself until either it sends a message that says, hey, I've run out of samples, the song is over, or I ran into an error during playback and I need to end, or something happens in the UI that is going to invalidate, that is both going to invalidate that audio pipeline and suggest that we need to replace it, right? So there's a couple of things that you could do in the UI that would do that. Like maybe it's like I click the stop button, right? So I need to actually stop that process, or I load a new song and then I hit play, right? Okay, now I need to replace the old pipeline, which is reading from the old file, with the new pipeline, which is reading from the new file, right? That sort of thing. Or the user has, plugged or unplugged their headphones. So you need to redo the sync, right? Those would be things that you might say, okay, once we do that, we make the change on our little builder object, we call build again, it spits out a new audio pipeline, and then we send that one over to the processing loop. It discards the old one, puts the new one in place, and starts pumping that, right? So that might be the conceptual way to think about it, is we're just producing audio pipelines in the UI thread, and we're feeding them over to the processing thread, which is then pumping them and processing until something causes it to stop doing that.
Okay. But what happens if you need to persist state between the pipelines created? If you disconnect your headset, do you expect the music player to still be at the point that it was before your headset, not to like completely restart and recreating the pipeline? I mean, I don't have seeking or persistence of that type set up yet, but I'm thinking about the future.
Yep.
So like, how would you persist this state? Although I'm now thinking that maybe we don't need to discard the pipeline itself when something of the sort happens. Like if you select a track, there is no unselecting a track, so to speak. When you get the output of the system, there is no unselecting the output of the system. So after the point where the pipeline can be created, I have the feeling that it can stay created and just swap out the parts that need to change. And then assume at every moment while it runs the processing loop that those parts are layable parts, parts that work, basically. You get what I mean?
Yes. Yeah. And yeah, I 100% agree. So you could imagine that, you unplug the headset and now you have to change your sync and your resampler, right? And maybe those things have to go together, right? So you could have a message that you send over your subscription to your background thread that says, hey, here's a new resampler and sync. So on the audio pipeline, you say, replace resampler and sync, because maybe those things can only go together. And then it will just swap those in place, right? So the audio pipeline is always fully initialized with something, right? So that processing loop can always keep running, right? It never has to stop unless you get into some sort of weird invalid state. Like maybe all the audio devices go away. In that case, you really are in a bad place, and maybe you do have to shut it all down and the user has to fix it up and then they can start again, right? But certainly as an iterative, as an iterative way of developing this, I think the first thing I would do is I would just take the audio pipeline and split it into the things I can manipulate, the things I can change on the fly while I'm preparing to commit these changes. And then the loop side where it's like, I always have a real pipeline and I'm just processing it. And it always has real objects, no options or anything. It doesn't have to check anything. And then after that, you can say, okay, now let's add some messages. I know I can replace the file on the fly, or I can replace the sync on the fly. And you can have messages which just do that. This can start to get complicated if there's shared state between the components that you're replacing. I don't know, on details. It's like, does your resampler depend in particular on how the decoder is working, right? You have to, you're making sure that if I replace the decoder, that the way that it's writing into the ring buffer doesn't like leave samples, unwritten, or, that you're just making sure that it's staying in sync with where it would have been if you didn't replace it, right? Sort of thing. But this is one of those cases where like you really want to be crystal clear on what it is your goals are, right? Because it may totally be reasonable for you to like stop the pipeline, do replacements, and restart the pipeline in some cases where you don't have to like do a bunch of fiddly work to try to figure out how to map everything, right? Maybe the user doesn't expect that like, oh, I can unplug my headset and I get perfect, flawless, no blip, in my audio stream out, right? It doesn't have to be perfect. I would just do the easy things first and kind of build on top of them as you become comfortable with them, and build up that process over time. Make it more complicated later.
Yeah, but when pitting each idea against each other, like which one do you think it's more adequate in this situation?
So, yeah, the way I would start is I would go for the simplest thing first, which is they've selected a file and they hit play. And I already know what the sync and the resampler are going to be. And I just take that whole audio pipeline and I send it over to my pumping thread, which then pumps it. And we don't worry about the headphone unplugging thing. All we worry about is, did the user select a different file and hit play, right? And if they do that, I just create another audio pipeline, send it over, replace the other one entirely, and start pumping the new one. Like that's the first step.
Okay. So no state transmission like between the pipelines, like it's just a new complete pipeline.
Yeah, because what you're going to establish here is you're going to establish that you have a loop that always depends on the fact that the pipeline is always valid. You only send valid pipelines to it, so it can depend on that. And you are working on this intermediate state only in the UI where you have the choice of file, maybe the choice of sync and resampler, and you're just collecting those things over there. Because right now you're kind of doing it all together in the audio pipeline. So the first stage is to split those concerns into the intermediate state and the final state, get that code written. Once that's satisfied, then you can say, okay, now I can send parts of my intermediate state over to the audio pipeline and have it do a partial update. That's like the second thing to do.
Okay, I think that makes sense. That's it, though. It's kind of segmented in its current state. Like everything related to output, let's say sample rate, getting the config of the default output device, is done right here. But I get what you mean. Like have a config, get that config through the decoding thread, and build a pipeline there. Any change, rebuild the pipeline. That's it.
Yep. Yeah, it's really easy to think about. I'm a big fan of I want to make it easy for me to think and reason about, because if I start having, if it becomes complicated and I've got, a dozen moving parts and any one of them could fail in strange ways, usually what's happened is that I haven't fully specified in my head what it really means to be in these weird intermediate states, because often you won't think about those until you actually run into them, right? Because there can be a lot of those states. So I like to make it simple. Like it can only be either fully specified or an indeterminate state that I'm not using and I don't care about. So this just makes it easier to make good progress in the application. And that, of course, that Rust doesn't matter whether it's Rust or anything else. That's just a general, application development.
Yeah. Although it's especially hard in Rust because there is this amount of concepts that you need to juggle the borrow checker and such. You cannot get away with doing what you want, quote unquote. But yeah, I get what you mean.
Yeah, I mean, sorry, just to that point, the nice thing about Rust is that it does not let you get away with that. Like I can't reach into another thread and poke at the contents of that audio pipeline and make those changes from the UI thread, right? And so Rust makes it really easy to say, hey, here is an audio pipeline object fully realized. I'm going to give it to the other thread. And now I know it's completely over there. And that thread doesn't have to worry about me making some random change over there. It has total control. So this kind of way of thinking works very well in Rust, and Rust makes it really easy to materialize it in your application.
Yeah, I agree. I think that solves my question related to how to structure the audio pipeline. I think we can move ahead with another question, unless you have something else to share.
No, this is for you.
All right. Yeah, the resampler implementation. Going to admit, I struggle a lot with doing the resampler, mostly because there are loads of math that you need to take into account the difference between frames and samples, and sometimes the rubato, which is the crate that I'm using, doesn't make it crystal clear which of the two you're using. So it was hard. Took a lot of tries, but I think I got the resampler working. At least it sounds good. I might figure out that something is wrong later on, but for now it works. So basically, as you can see here, it's very, very, very messy. There is logic pretty much tangled, and then there is logic repeated, but it's slightly different. And I haven't done the effort of refactoring this. I literally was working on this yesterday, but I wanted some pointers on how to untangle this mess, basically.
So can you describe to me, maybe at a high level, how the resampler works? Maybe not at a high level. I really actually want to know the low level of it. What is this function doing? And let's just walk through it and kind of describe, here are the steps that it is going through.
Sure. I go from top level to bottom. You use the resample in two places, really. You use it when you have decoded samples, right? You want to resample them if the sample rates of the input and output do not match. And the other case where you want to use the resampler is to flush the remaining data that is in the resampler, because resamplers seem to have this delay in which the frames that you introduce first are padded to the left, with some silence, so the calculations for basically the resampling work. I'm not that well versed in fast Fourier transformations, but that's the gist of it.
And this is because you're changing frequencies. Or sorry, you're changing the sample rate. Yeah.
Yeah.
Okay.
So I won't go too much into details about why that's the way it is, because again, it's still a bit too in the air for me as a concept. I need to like read more. But yeah, that's the two places where you want to use the resampler, to resample the coded frames and to flush the remaining when the decoder stops. Like there are no more packets or more samples to get from the file.
Okay. So I think I understand that. And looking at so let's just walk through your code here, and I want to make sure that I understand like how the flow of the code, what transformations it's doing at each level, because I see some things in here which are already giving me some ideas about how to clean this up. But I'd like to go from the top of the function and let's take a look at it.
Sure.
Can you go up to the top of that function, and I want to see.
Oh yeah.
Yeah.
Sure.
Okay. So this process. This is not the resampler.
No. This is the pipeline.
Okay. Yeah. So let's go look at. Oh, hold on a second. Was that? I apologize. Let's go down a little bit further because I saw a stereo versus mono comparison down here, or where the channel numbers were different. Right here, down at line 317. Oh yeah, I guess they're at 303 too.
Oh yeah, I think I have to mention this. To reduce the amount of work that the resampler has to do, I try to go to the lowest amount of channels, like before or after the resampling. Let's say, for example, you have an output channel count of 2, like a stereo, and you have a mono track. If you were to like convert the channels to stereo, you will have like to do more work because then it's 2 channels instead of 1, more samples per frame, and overall it wouldn't be as efficient as if we just convert the channels at the end. And same thing will happen in the opposite case, right? If you have a stereo track and then you have mono output, you will first like do the conversion from stereo to mono and then work with the resampler in mono. So that's a little detail that I forgot to say.
Yeah. Okay. So, and what I'm seeing here, tell me if I'm wrong. So this is your processing loop. This is the thing that's pumping the pipeline, right? This is pumping all of the data that is in the audio pipeline from each piece to the next piece. And then at the end, you write out everything to the audio device, right? The final audio device.
Not to the audio device, but to the sync.
Yeah,
and
to the sync. Right.
Pushes to the rim buffer of the engine.
Okay.
And if there is an excess, it stores it as a buffer.
Okay. Yeah, and then that's what goes out to the audio device. It's probably pulling from the ring buffer on a continuous basis, I assume.
Yeah.
Yeah. Okay.
Yeah.
So this processing loop is responsible for doing that, but I also see that it is making some conversion decisions within this processing loop. If I'm reading this correctly, right? It's looking at the number of track channels that you have, and it's doing some conversion there within this processing loop, right? So if I understand it, so the way that I normally would think of a pipeline like this is this processing loop, the only thing it would do if it does much of anything at all is pulls the data from each component in the pipeline and pushes it into the next component in the pipeline, right? And does nothing else. And if there are transformations that need to happen, what I would normally think of is you'd have another component in the pipeline that's responsible for that. So thinking from an architectural and like a data oriented design standpoint, I'm thinking of I have bytes that are coming in at some level in the pipeline, and I run a transformation on them, and I get some other bytes out the end, right? And then those are the input bytes that go into the next pipeline, and it does its transformation, and I get new bytes out, and so on and so forth. And I can link those up as many of them as I want, right? And in the simplest ideal case, all of this processing loop is doing is going through each pipeline stage and getting bytes, putting bytes in and getting bytes out and moving them along, right? you might be able to imagine if you just accept that works and just set aside the technical details for a moment. If you accept that works, you can then imagine a even more advanced pipeline where all your processing does is say tick the pipeline, right? And then each of those components is linked to each other, and they can just talk directly to each other. Like the decoder knows who the resampler is, and the resampler knows who the sync is. And so as each one consumes bytes and produces bytes, it just sends it to the next one along the line and along the line and along the line. And eventually it makes its way to the sync, right? And all that, then that processing loop actually knows nothing about the way any of the pipelines work. It barely even needs to know how they're connected. It just knows that they are connected. And it just needs to tell, the first one or the last one or whatever it is, hey, you've got some time slice, go do some work, right? Or maybe it's all driven from the sync side, where it's like the sync notices, oh, I've got space in the ring buffer. I can accept another 20 bytes. I tell, the guy who's feeding me bytes, hey, give me some more. And if he needs more, he tells the guy above him, hey, give me some more bytes, and so on and so forth. You could imagine that a system like this could evolve that way. So what that makes me think of here is that this bit, for example, where you've got the stereo channel manipulation in here, this I would probably promote to another pipeline stage as like a first step, right? Maybe it goes in front of the resampler, right? So the decoder goes to the channel converter, and then the channel converter goes to the resampler, or vice versa, right? Not exactly sure, because it's going to be on technical details. As you say, we want to be efficient about it, so we don't want to do more conversions than we have to, especially if we're doing like mono to stereo. We'd like to only convert once and not twice. So I could imagine, like, I would add another stage to the pipeline that lets me do that. And then I would try to organize it so that the data that's coming and going to each of these things is uniform from the perspective of this processing loop, right? That ideally it doesn't need to know what, whether I haven't looked at, for example, your decoder. I assume your decoder puts out U8 vex or something. What does it actually put out?
It puts out, it's right here, an option of a
F32
vector F32, yeah.
Okay. Yeah, and I assume that when you created the decoder, whether that buffer was going to be stereo or mono, right? Like, what that, so it's like implicit in the decoder.
Well, do you mean the sample rate and channels of the output, or do you mean the input?
Yeah, it's like what the format, what that vector of F32s actually represents, like whether it represents a stream of mono samples or whether it represents a stream of stereo samples, like you already know, right? Yeah. So then if that is only working in Vec32s, then presumably the input to the next stage, which is the channel, I guess it's the channel manipulation, the channel decoder, which is which is in here. So after decode, so we do decode, we get the decoded samples, we
do the conversion if
we
it's
may or may
going
not
to
do a conversion.
Yeah,
And then
it's optional.
okay. Yeah. So this is, so I understand why you've done it this way, because you may, or the order in which you have these stages configured might be different depending on what the overall shape of the pipeline looks like, is what it looks like to me, right? You always have the decoder as the start, but you may or may not need to run the resampler first, or you may need to run the channel converter first, depending on what the format is, right?
Yeah, depending on what's most efficient.
And do the resampler and the channel converter, do they both just output vecs of F32s?
Yep.
Nice. So it could actually be pretty straightforward, where you're just inputting bytes and outputting bytes, and this loop doesn't really need to know what they are, other than that they're vec F32s. Like we've standardized on that, but you do need to know what the ordering that you run these stages in is, right?
Yes.
So, what I'm thinking here is that maybe what you have, maybe this audio pipeline really does, maybe the next thing you do is, well, the first thing I would do is make a stage, which is this conversion stage, and put it into the audio pipeline as like its own object, It's like, this is the thing that converts channels, right? And it converts either up or down. And the way that you might do that is, I think you have two different kinds of them here. One that's sampling up to more channels and one that's sampling down to fewer channels. Or are they the same?
No,
Oh, no,
they are the same. Yeah,
Okay.
we are just deciding when to change to the output amount of channels.
Right. But they have their own, they have specific parameters, but the parameters that you have there, the decoder track channels and the output format channels, those are fixed at the time you load the file, right? Those can't change over the course of the file.
Yeah, I mean, the same input goes through these stages if they are present, like if they are going to run.
Yeah. So I could imagine then that you have another field on there, which is your channel converter. And when you construct the pipeline, you set the parameters on the channel converter to be, here's what the input channels number of channels are. Here's what the number of output channels are. And then you stuff that constructed object into the audio pipeline. And now you have your channel converter. You no longer need to pass any of the channel numbers anymore because they're fixed already at the time you construct the pipeline. They don't change over time as you're like playing a file. And then the only choice you have to make is, do I call it before or after the resampler, right? Because that's what you're doing here, right? So you're kind of removing this custom logic from inside of here and saying, well, rather than, making this call to this channel converter, I'm now making a call to the pipeline entry for channel conversion, right? And the reason I'm saying this is because the next logical thing that you do is you take all of those pipeline things and you put them into a vec of pipeline entries, right?
And then you execute them in that.
And then you just execute them in each order, right? And you start with an empty buffer that goes into the decoder, and the decoder spits out a buffer that's filled with something, and then you take that one and you put it in the input to the next level of the pipeline. And so now you make your channel conversion ordering choice by altering the order of that vector when you construct the pipeline. So I can put it before or after, depending on whether my channel conversion needs to be, upsampling to stereo or downsampling to mono.
And I could go even further by including or not including the resampler in the first place if it's not needed.
100%, right? So now you're free to add and remove plugins to your pipeline, which could be filters. They could be whatever you want. I mean, once you have a pipeline like this where you don't care about what the pipeline is doing, you only care that the data is moving along and the data is opaque to your loop, you can then construct the pipeline to be whatever you want.
Okay.
So the one thing that will be, well, actually, no, this isn't even tricky. I was thinking if for some reason you have, well, okay, so there is a caveat here that makes this ever so slightly more complicated. If you're going to have a vector of arbitrary pipeline entries, they obviously cannot be structs that have specific types, right? You have to erase the types for those because you can't have a vector of different pipeline types, right? So you'd have a trait, right? That is like, and all the trait does is have like input and output, right? Or, it just has process and it takes as an input a vec of F32 and as an output, you get a vec of F32, right? And then all the process loop is just going through each of those, making those calls, and it does the right thing. Now, you're going to, the thing that you're going to run into is probably that you already have taken care of here is that not every time you process one of these parts of the pipeline, you don't always get out like the same amount of data as you put in, right? It's been transformed, it's been expanded, or it's been compressed. And the way that the amount of time it takes for the sink to actually consume everything, you'll have to run the process loop on some cadence that makes sense for ensuring that the sink is never starved and that you always have enough time to produce samples from the rest of the pipeline to make it to the sink, right? So you already do something like this. So you'll still have to figure out how to communicate that information from the pipeline, back into this processing thread so that it can do the right thing. And in theory, this is something where since we know how long it takes for the sink to consume data, we should be able to kind of predetermine how much, well, actually, maybe we can't from compressed data because you might get different amounts of actual data out of compressed data each time you make a call. So it starts to get complicated. but I'll leave that as an exercise to you to figure out how to do that. You've already solved it here. You would just extend it to an arbitrary pipeline where this loop no longer cares about what the shape of the data is or even what the contents of the pipeline is. It knows to just walk through the pipeline.
Yeah, actually, yeah, that's a pretty good, I would say, evolution of the system.
And just to give you this is a very standard way of thinking about this. So the company that I work for, we have audio pipelines that look exactly like this. Like when they're constructed, they pick all the different things that need to go into the pipeline, smash them together, and then they just run as a series. They obviously have, since they're running a real-time system in a game, they're very concerned about performance. So, they do a lot to ensure that they're only doing as much work as they need to, but that they're also doing enough work that they never starve the audio pipeline. So, there can be details about, am I reusing buffers or am I allocating every frame, right? I'd like to reuse buffers if I can. So you might end up later on thinking about, rather than creating a brand new vec every time, maybe you just have a recycled vec that each that each part of the pipeline holds onto, and it just passes around references to that, right? That can go on to other stages of the pipeline, right? As they're needed. And maybe each stage has its own so that they don't have to keep reallocating, right? Maybe in some places you can use fixed buffers, maybe some places not. But that's
so if I understand correctly, it's like a reference to a specific step in the pipeline, a specific entry, and like manipulating that entry from basically from wherever you have the reference to that entry.
Mm-hmm.
So this is how you could theoretically make the seek in, I think, though. Like, how would you interact with different entries if every entry is generic? You cannot know which is the decoder, which is the resampler, which is the,
Right. Well, so you have to make sure that your trait that controls what this pipeline entry looks like has sufficient information in it that you can communicate what you need to between each of the stages of the pipeline. So, you could imagine, and in this case, just to be clear, this is an optimization case, right? This is something that you get to later when you're really deep into it, and not something you would have to do immediately. So don't let the potential complexity stop you from evolving the pipeline closer and closer to this. But you could imagine that your main processing loop has a pool of buffers, and it asks each plugin or each stage of the pipeline, hey, how big of a buffer do you need, right? And it just holds on. It just keeps those buffers lying around and passes them on to each one. And each one takes that buffer and does some manipulation on it and hands it back, right? And it can be borrowed because the outer object, the processing loop, holds it, right? So those objects don't have to necessarily hold any of their own data. They just take these working buffers, and the processing loop can be passing around that shared buffer to each of these other components, right? You can imagine something like that.
So it's like event-driven. Well,
it's not quite event-driven because your processing loop is still asking each stage of the pipeline, hey, what do you need, right? And then it gives you an answer, and then you give that to it, and then it gives you back a response, and you take that, and you go to the next stage of the pipeline and say, here's the thing that I'm giving you, what do you need, right? And then you answer that, and then it goes through and gives you back another answer, and you just do that. So it's a staged thing. It's not necessarily event-driven. You're polling in this case rather than being given events. And it's much easier to think about polling than it is to have event. You could definitely do it event-driven. I probably wouldn't. That'll just make things more complicated. But yeah, that would be another way. And this is, again, optimization later on when you're trying to really, close down on, I want to reduce allocations. I want to reduce the amount of latency at my system, et cetera, those sorts of things.
That said, I think it didn't land the explanation on how to communicate with the entries. Could you repeat that?
Yeah. So, imagine you have your pipeline and it has a vector of all of your pipeline entries in it, right? And there's a trait there which has all of the functionality on it that you need to communicate with each of those entries, right? So they have to be the same shape. So the trait will have to be the same on each of them, right? So there's only so much information you can actually communicate between the stages of the pipeline because the trait only has, certain very generic functions on it. I take some inputs, I produce some outputs, and if I have anything else, if I want to be able to ask questions of the system, they have to be something that any stage could ask and you could give it a sensible answer, right? So, it could be something like, hey, this stage of the plugin, do you need some memory? How much memory do you, tell me how much memory you need, right? And then it gives you an answer, and then you can make another call into it and say, okay, here's the memory you asked for, right? And it could just keep doing that. And the reason you might do this is because largely these plugin or these stages are going to keep asking for the same amount, for example, the same memory, right? So you can just keep handing them back the same memory object, right, without reallocating it, right? So this would be a way to perform reuse. And that's just one example of a thing that you might have. You could also potentially have, you do different traits.
No, I didn't mean it in the sense of sharing memory. I mean it in the sense of like issuing a command to any specific part. Let's say I do, again, the example with seeking like a particular frame count. Let's say I want to seek to the half of the song, and I need to communicate with the sampler. I need to communicate with the decoder, and basically tell them, hey, we are now at the middle of the song, minus some delay, of course, because the decoder needs some priming frames. So yeah, start working from there, or move to that position in the track.
Mm-hmm.
How would you like implement it in that sense?
So this is the case where you both you need specific control for some, you need the ways to make specific control of certain stages of the pipeline that don't apply to other stages of the pipeline. So for seeking, for example, what you're really saying is I think what you're saying is that like at the decoder level, I want to say, hey, I'm moving back to 10 seconds ago. Start decoding from there, right?
Yeah.
Something like that. So if your decoder is both a stage of the pipeline and like supports seek, for example, what you would want is some way for when you construct the audio pipeline to identify that this object is the decoder and it's the thing that seeking does. And so on the pipeline, you might have a seek implementation. And when you add the decoder, it might know, or you might want the audio pipeline to know, hey, the decoder is this object, and you give it its real type, right? Or you give it a type that implements iSeek, seek. My C++ is coming out. And so you hold on to a reference to that in the audio pipeline. But in addition, you put a reference to the decoder into the pipeline stages, right? And that's the thing that has the trait of, pipeline stage, for example. And so here in the process loop, whenever you get a command from the UI that says seek, right, it will make a call on the audio pipeline to say seek. And then because the audio pipeline knows which stage is the decoder, it knows what the decoder object is, it can make the call directly onto the decoder stage to do the seeking, right? The processing loop just continues to loop over the entries in the pipeline stages and move the data around. But you have special entry points on the pipeline that correspond to these very specific capabilities that the overall pipeline supports. The overall pipeline supports seeking. The overall pipeline supports stopping, right? But the audio pipeline, when you construct the object, it gets the actual underlying objects. It understands what those are, and it knows then how to take those logical operations of seek, stop, restart, and make the appropriate calls to set the state for the individual pipeline stages so that when the processing loop is running, it does the right thing, right? I think that's the way I would do it. So, but what this means is that when you are constructing your pipeline, some of those stages are going to be special. They're going to be special in that the audio pipeline needs to know about them specifically, right? Yeah. There is another way that you could do this. The other way to do this is that you have pipeline stages that those all implement all of these commands. And when you get so they all implement stop, start, restart, whatever. And for those stages where it does not matter, They just ignore them. But for those stages where they do matter, it does whatever needs to happen. And so when you get one of these commands like seek, the processing loop goes through and just calls the seek function on every single one of the pipeline methods in order, right? Only the decoder is going to do anything with it because that's the way you've defined it to work. So you can still have just a completely generic audio pipeline that has no special behavior in it, but you then need to make sure that every stage of the pipeline is able to respond to those commands so that it can do the right thing. And the caveat here is that if there are interrelated behaviors that must occur because of a particular command, like maybe seek requires both that you change where the decoder is starting from and, I don't know, you need to reset the ring buffer or something, like, if that was a thing. If there's like an ordering, like if that ordering is different than going from start to end in the pipeline stages from the processing loop, then this breaks down and you have to come up with some other scheme by which you communicate all of the right information to each of the stages of the pipeline. Typically, I don't think that's going to happen because usually in audio pipelines, things change from one point and they affect everything downstream, but they don't change at the end and affect everything upstream unless you are like completely like resetting the pipeline, typically.
Yeah.
You will, of course, run into corner cases, right? And I can't answer here what all those corner cases might be, but this gives you kind of a strategy of thinking like I could store specific objects in the pipeline and make the pipeline aware, or I can just add a trait to all of the objects in the pipeline stages and each stage only pays attention to the commands that it cares about, for example.
Okay. So I think the most idiomatic way of going with this will be to have this audio pipeline step entry struct to have a handler for commands so that it can receive particular commands. Let's say now I'm thinking if I should like split the audio pipeline commands and the audio step entry commands, because it will be the same, right? It would just tell to every single entry, hey, we are seeking to this amount of frames, right? But then it opens the question, should it be the same? Should it be different?
Mm-hmm. I mean, and you could, like, your trait can also communicate, like it could communicate capabilities. So you could imagine that every trait has a capabilities method on it, and that returns a set of flags, for example. And then, maybe when you get the seek command, you look for all of the pipeline entries that have the capability seek, right? And that those are the ones that you send the seek message to. You could imagine that, rather than having special functions that are like seek, stop, start, instead each pipeline entry has a command function which takes a command, right? And that command could be any of the ones in your enumeration, seek, stop, start, whatever. And then you could call that, right? You could get that granular if you wanted to. I don't think you would start there, but you could imagine that might be a way to allow your pipeline to be composed in, it can have all sorts of different capabilities without having the trait itself have to expose all of those capabilities specifically.
Yeah, and that could be the internal implementations of that particular step.
Yep.
Okay. Yeah, I realize now that the resampler question bleed down into more structuring, code structure, architecture of the audio pipeline.
Yeah, that's good. Like that's what I normally expect. So, these pipelining things, this is actually a very technical implementation. And the cool thing about that is that it lends itself to kind of particular ways of thinking, either in Rust or really in any language, ways of taking what is blocks of code that are like this and breaking them up into individual pieces that you can reason about easily and also reason about uniformly, right? And then you can compose them in whatever way you want without having them being, structured very rigidly in the code. So this is a very common thing to happen. And honestly, when I'm writing any application, the first thing I do is make it work. And the second thing I do is make it nice, right? I mean, the more you write applications, the easier it is to do architecture up front. But sometimes it's better to just make it work and then see what architecture naturally comes out of it. because it's not always the case that you choose the right architecture up front, because you don't always know what it really is you want until you've played around with it for a while.
You kind of paint yourself in a corner if you don't understand the problem completely and all the moving pieces between the models.
If you're working through similar Rust challenges and want experienced Rust engineers reviewing your code, helping you with architecture decisions, and answering your questions live each week, check out the Rust Live Accelerator by heading over to letsgetrusty.com/join, or by clicking the link in the pinned comment below. Hope you've enjoyed this episode of Rust Code Clinic, and remember to stay rusty.